Hello class, this is Lesson 3 in Module 1, Identifying Proportional and Non-Proportional Relationships in Tables. The student outcomes for this lesson are: students examine situations to decide whether two quantities are proportional to each other by checking for a constant multiple between measures of x and measures of y when given in a table. And students study examples of relationships that are not proportional in addition to those that are. Our essential question for Lesson 3 is: how can you use a table to determine whether the relationship between two quantities is proportional? Pause the video and copy that question. In Example 1, you have been hired by your neighbors to babysit their children on Friday night. You are paid $8 per hour. Complete the table relating your pay to the number of hours you worked. To fill in the table, 1 hour will earn $8. 2 hours you will earn twice as much. 2 hours times $8 each is $16. 3 hours times $8 each will be $24. 4 times 8 is 32, and so on. Pause the video and figure out how much you would earn if you worked 4.5 hours and 6.5 hours. So to find the amount for 4.5 and 6.5 hours, you would still multiply by 8. So 4 times 8 is 32, and then half an hour you would get $4, so 32 plus 4 more dollars is $36. And for 6.5 hours, 6 hours times $8 each is $48. And then for the half hour, you would earn an additional 4 hours, $4, so that your total is $52. Based on this table, is the pay proportional to the hours worked, and how do you know? The answer is yes. This is proportional data, because the number of hours is always multiplied by the same number, in this case 8. And we prove this by saying 1 hour times $8, 2 hours times $8, 3 hours times $8, etc. Since the multiplier is the same for every pair, this is a proportional relationship. For the next exercise, Exercise 1 through 3, determine if y is proportional to x and justify your answer. In other words, how do you know? The table below represents the relationship of the amount of snowfall in inches in 5 counties to the amount of time in hours of a recent winter storm. So our variable x is the time, and the snowfall, variable y, is recorded. So in 2 hours, 10 inches of snowfall happened. In another county, 6 hours of 6 hours and it snowed, and you got 12 inches of snow. In 8 hours, there was 16 inches of snow. In another place, 2.5 hours, it equaled 5 inches of snow, and 7 hours, and there was 14 inches of snow. And the question is asking, is this data proportional? In other words, did it snow at the same rate in all of the locations? So we want to look and see, is there a multiplier that is going to be the same for each pairs? So here the multiplier would be 5. 2 times 5 is 10. You could also divide y divided by x to find the multiplier. So 10 divided by 2 is 5. 12 divided by 6 is 2. So here the multiplier is 2. 8 times 2 is 16. And 2.5 times 2 is 5. And 7 times 2 is 14. So in all of the pairs except for the first pair, the multiplier is 2. But in order for it to be a proportional relationship, the multiplier has to be the same for every pair. So this is not proportional because the time is not always multiplied by the same number. In example 2, the table shows the relationship between the cost of renting a movie in dollars to the number of days the movie is rented. So here, if you rent the movie for 6 days, it will cost $2. If you rent the movie for 9 days, it will be $3. 24 days is $8, and 3 days is $1. And the question is asking, is it proportional? In other words, is it the same rate per day? To figure that out, you can either do 2 divided by 6, in other words, y divided by x. So 2 divided by 6 is 1/3. 2/6 is equal to 1/3. And then following the same pattern, 3 divided by 9, 3 over 9, that also equals 1/3. And this is looking like it might be a proportional relationship. 8 divided by 24 is 1/3 because 8 over 24 simplifies to 1/3. And 1 divided by 3, 1 over 3. So these all have the same unit rate. And for that reason, this is a proportional relationship because the number of days are always divided by 3 to determine the cost. The number of days is always divided by 3 to find the cost. And because that has the same divisor for every pair, this is a proportional relationship. In question 3, Randy is planning to drive from New Jersey to Florida. Randy recorded the distance traveled and the total number of gallons used every time he stopped for gas. Assume the miles driven are proportional to the gallons consumed in order to complete the table. So in this problem, you are not given every pair and you have to do the division. They're giving you the pairs for some of them. And then you need to figure out how many miles you're getting for 1 gallon of gas and use that information to figure out the rest of the chart. So in our example here, 2 gallons of gas gets you 54 miles on the highway. So you have to figure out, well, how far can you go on 1 gallon of gas? So remember that your first number in the chart is the x value, and the second number in the chart is the y value. And to determine the unit rate, it is y divided by x. So 54 divided by 2. And 54 divided by 2 is 27. What that means is it's 27 miles per gallon. Since it's 25 miles per gallon then, 4 times 27 tells you how many miles you get with 4 gallons of gas. Here, 8 times 27 equals 216, and 10 times 27 equals 270, and 12 times 27 equals 324. Now, pause the video and figure out how many gallons you would need to drive 189 miles. Now, the answer is not 6 here, and some people think it is because 2, 4, 6, 8, 10 is a pattern, but it is not 6. Pause the video and see if you can figure that out. So the correct answer for that problem is actually 7. And to figure that out, all you want to do is divide 189 by 27. 189 divided by 27. And the reason that works is because if you're going from the y value to the x value, the opposite of multiplying to get the number of miles is dividing to get the number of gallons. So you would take the number of miles and divide by 27 to get the number of gallons. And 216 divided by 27 is 8. And 189 divided by 27 is equal to 7. So this is the number of miles. Oops, let's put that back. And 27 is the number of miles per gallon. And then 7 represents the number of gallons. In summary, the quantities are proportional if a constant number exists, and that constant number can be a multiplier or a divisor. Let's get rid of that. That constant number can be a multiplier or a divisor. Exists that each measure is the first quantity is multiplied by this constant gives the corresponding measure in the second quantity, which is y. So what that means is going from x to y, that there is a constant number being either multiplied or divided. In this case, the multiplier is 27 times 27 times 27 times 27. One quantity is proportional to a second if a constant number exists such that each measure in the first quantity multiplied by this constant gives that corresponding measure in the second quantity. Next, we're going to turn to page 14 and do one example from lesson 4. Please turn to page 14 in your book. On page 14, this is from lesson 4, and we're going to do example 2. Mark recently moved to a new state. During the first month, he visited 5 state parks. Each month after he visited 2 more parks. Complete the table below and use the results to determine if the number of parks visited is proportional to the number of months. I'd like you to pause the video and see if you can fill in this table. Remember that in the first month he visited 5 state parks. Then each month after that he visited 2 more parks. Pause this and fill in the table in pencil. When you're filling in this chart, the first month is 5, and then in the next month he visited 2 more parks, so now he has visited 7. And then the next month he visits 2 more parks, so in the third month he had visited 9. Now pause the video if you haven't and see if you can figure out what the answer would be for the number of months for 23. And making a table, extending it from 1, 2, 3, 4, 5, 6, will help you figure this out. The correct answer is 10 months. So you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And following the pattern of 5, 7, 9, and notice that it's increasing by 2 each time. So this is a nice pattern that we can continue. 11, 13, 15, 17, 19, 21, and 23. So the answer is 10 months. Then it says, determine if the number of parks visited is proportional to the number of months. Now, it's important to note here that just because it has a nice pattern does not make it proportional. So this answer is no. It is not proportional. It's a nice pattern, but it is not proportional because there is no multiplier that works for every pair. There is no multiplier. 1 times 5 equals 5. 2 times 3½ equals 7. 3 times 3 equals 9. Since this multiplier is different for every pair, this is not a proportional relationship. That concludes Lesson 3 and part of 4.